Okay, let's take a look at the solution for the crosstalk interlocks between two controllers. What I've done here is I've developed this on Siemens. You were asked to develop one of the programs on Siemens and one of them on an Allen Bradley. This is what I just put it all on one to kind of show you what each program would look like. This really isn't the application because the goal was to have two different PLCs, not one PLC up here. We wanted two. But what I did, I didn't do much scheduling here. I just created two routines called master and slave. I probably would have put these into a subroutine and then unconditionally scheduled it out of the main OB. But let's take a look at this. So the first thing that you needed to do was you needed to make the connections. The master PLC had to have I/O wired into it, but it had to have control relay 1. The master must turn on a control relay 1. Okay? The control relay 1 contacts must be wired into the second controller that I've called slave here. Okay? And now the slave controller must have control relay 2, and so the slave controller has to turn on a relay, and the contacts from that control relay 2 must be wired as an input into the master of 1. So that's how they're talking. Master 1 turns on a relay, the contacts close on the slave. The slave turns on the control relay, the second control relay, and the contacts close on the master. That's how they talk. Okay, so here we go. This needed two system bits. So it said PB1 turns the system on. So basically I hit PB1, and apparently I've got something here that is going to be coming as true. Okay, and then I have a system bit coming on. So my system bit would come on, and this thing would be held right here. Okay, and that just powers up my system bit. So what I did with my system bit was then I put it in front of these here so that nothing was going to occur unless the system bit was on. And the system bit, you could turn on a light to let people know that the system bit is on. Okay, so maybe I should have put a light here. Okay, the next thing we did is we hit the start process here. Okay, so when I hit the start process, what I did is I brought on another bit, and that's the system run bit. And I use the system run bit to hold itself on. So maybe you would want to have another light here. One light would be that the system is on, energized, and the other light might be that the system is now running. Okay, but we would know that the system was running because if these were true, if the system bit was true from above, and I pushed the process, this run bit would come on, which would start this blinking light because the system bit was true, and then the system run bit was true. So these become true because we've pushed push button 1 and push button 3, and they're in their memory. So the light comes on. Okay. Now we got to turn the light off. So the system run bit, what that does is it starts the first timer. And when the timer gets done, I didn't use the timer.q. I put an M bit on here. I recommended using M bits on here. So this gets done. This is the blink timer. So what this has to do is turn off the light, and that's what it's doing right there. So the system run bit right here turned on the light and the timer turned it off. Now this also gets done, and it's got to start the reset timer. So when this gets done, it starts this, and then the purpose of this timer is the reset. So when that gets done, what I did is I just opened up this contact here, which would reset this, reset this, reset this, reset this, and reset this, and it would start again. I guess that would get reset as well, and light would come back on, and then it would run that progress, and it would go off, and then it would start again, and it would keep going on and off. This timer done here, once again I used a M bit instead of using the .q. What this does is it counts closed. Every time it gets done, this counts up 1, 2, 3, and it counts up, and then I get this crosstalk right here. Counter 2 being done, I turned on this bit. Okay, I didn't use a Q off of here. I put a M bit. So I use that done bit to turn on the crosstalk relay. So if this crosstalk relay is coming on, that means that the light is blinked 3 times, and now this controller has to talk to the other controller. Okay, so what this does is it closes, and the other relay is going to, or the other program is going to start. So the crosstalk relay occurs here. Okay, so if I were to look at my other controller, let's see if I can pull that up. I'm getting a crosstalk from the master PLC, and that was the relay. The relay on the other one closed, and it was wired into input. So this is going to be held because we didn't reset the counter. So because this is done, this stays true until this gets reset, which means this crosstalk relay remains true. And so this contact on the other controller remains true. And what does that do? That turns the light on. And very similar to what we did last time, this crosstalk from the master has to be true, and it's going to be held true. And so this is my blink timer. Timer 1 done. That blinks the light. And this is my reset timer. So when this one gets done, it starts the reset timer. The reset gets done, opens up, which resets this, and 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 resets that. And the lights blink again. So this thing starts blinking. Just like we did last time, we did a counter. It goes 1, 2, 3. The counter gets done. When the counter gets done, I used a bit instead of just using the .Q. It turns on a crosstalk relay to tell the other controller, hey, I'm done. Okay, so this is going to turn on. Well, a couple of things that I did is I used another set of contacts from here. So if this crosstalk relay becomes true, then in order for it to crosstalk, I'll go back to here, I've got an option here to start this again. Okay, one thing we did though here is that after this counter got done down here, when it did 3 times, it crosstalked, and then it killed the memory on this run right here. So our first process died. But when the second controller finished up, it closed this relay again. It closed these contacts because the slave controller came on, and then all of a sudden I'm going to have memory here again because this will become true, and then this will hold, and I'll have memory, and this process is going to take off again. But what I did was I used the contacts, another set of contacts of the slave controller, to reset the counter on this unit here, and then this whole thing will reset. Why did I use the contacts of the relay? Well, if the relay gets true here, and this gets true, then that means that these contacts must have been made. And that means that these contacts must have been made, and so now we're rolling along again. And so basically that CR2 is just going to come on and come off real quickly. This runs again, and it goes back and forth, and then it will start the other one, and it's going to kind of go back and forth with this one running, and this one running, and this one running, and this one running. I'm using those CR2 auxiliary contacts because that was the contacts of the slave controller. So every time these close, that means that the second process is done. So this is going to close, 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 and then my cycle counter will get done. And when that's done, that will open up, and that will kill the whole system because the system bit was the first thing that we energized at first. Okay, so you can kill it by having everything done, or you could hit the stop button right there. So that was my solution. I hope you understand how to blink the lights, and some way you needed to be turning on this crosstalk here, this relay, and then it needed to be wired into the input of that needed to be wired into the second controller to start that. And when this controller got done, it needed to turn on a relay. And the contacts from that relay needed to be wired back in to the first controller and to somehow start the process again. So this was one way to do it.